All right, in this problem, we're going to look at dividing fractions. And in dividing fractions, we have a couple of steps here. In dividing fractions, first you're going to want to factor both the numerator and denominator of the first fraction first. Then you're going to change the operation from division to multiplication. And then you're going to kind of do two things in the third step. You're going to factor the numerator and denominators of the second fractions, but at the same time, you're going to flip that fraction. So you're going to factor, and then you're also going to flip the fraction upside down. Because when you divide fractions, you multiply by the reciprocal of the second fraction. Once you have that, you basically have yourself a multiplication problem like we did in the previous step, in the previous problems. So here we're going to cancel common factors, and again it's only one from either numerator with one from either denominator. And once you've done that, now you can just rewrite your final answer. Okay? So let's look at a couple examples. Okay? In problem number 8, doesn't look like we have any factoring to do in this problem because there's no addition or subtraction anywhere in the problem. So just a matter of switching this to multiplication, flipping, and canceling. So in this case, we're going to have a 7x to the 4th over 24y to the 5th. Then we're going to switch this to multiplication, rewrite our second fraction with our denominator becoming our numerator and our numerator becoming our denominator. And that's just a matter of canceling. So can we cancel with a 7 with any of the terms on the bottom? Apparently so. And it looks like this 7x to the 4th can cancel with the 21x. Again, since everything is multiplication here, we can cancel any way we like. So the 7 is going to change the 21 into a 3. And this x is going to change that x to the 4th into an x cubed. Okay. Then we move on to the other numerator. Looks like we have 12 y to the 4th, which could cancel with a 24y to the 5th. Again, these can cancel because it's all multiplication, so we can cancel the various pieces of those terms. So if we cancel this with this, 12 goes into 24, it leaves you with a 2 in the denominator. And this y to the 4th can cancel with the y to the 5th. Those 4 y's cancel with 4 of those y's, which leaves you with a single y on the bottom. And then now there's nothing left there other than a 1. So at this point, we can go ahead and write our final fraction on this problem. Looks like the only term we have left in the numerator is an x to the 3rd. And in our denominator, we have a 2y multiplied by a 3, which gets you a 6y. So there's your final reduced fraction. Okay? So let's look at number 9. Number 9, here we do have addition and subtraction, actually just the subtraction problems in here for our terms. So there will be some factoring in this one. So recall our steps. The first step is going to be to factor the numerator and denominator of the first fraction first. So we'll go ahead and do that. Looks like there's a common factor. Remember, always greatest common factor first, greatest common factor first, greatest common factor first. And in this case, there is a common factor of 2, which leaves you with something minus something. Take a 2 out of 2x, and you're left with an x. Take a 2 out of the 10, and we're left with a 5. So let's do the denominator. Check for common factor. There is. Looks like 3 and 21 has a common factor of 3, which leaves you with something minus something. Take a 3 out of the 3x, it leaves you with an x. Take a 3 out of 21, and that leaves you with a 7. And recall, on greatest common factor, if you redistribute this, you should get those two terms. 2 times x is 2x, 2 times negative 5 is negative 10. 3 times x is 3x, 3 times negative 7 is negative 21. Okay, again, I like to call this opposite of distributing, okay, because we're undistributing. Then we're going to take the division, switch it to multiplication, and then we're going to factor both the numerator and denominator, but they're going to get flipped, which means this numerator is going to be our new denominator, and our original denominator will be our new numerator. So let's start at that point. Looks like we have a common factor here of 4, because 4 goes into 28 7 times. So we take a 4 out of the x, 4x, which leaves you with an x, and then that's minus, take a 4 out of 28, and that leaves you with a 7. And as far as the numerator goes, there doesn't appear to be a common factor, and since there's not a squared on the x, and 5 is not a perfect square, this is obviously not a difference of squares, so this is already factored. And since there's subtraction there, it might be helpful to throw parentheses around there so we don't accidentally cancel incorrectly. Okay? So at this point, we're ready to start canceling one thing from the numerator with one from the denominator. Well, we look and see, is there a 2 all by itself down there, or a number that's a factor of 2? Doesn't appear so. So we move over to the x minus 5. Do we have an x minus 5 in the denominator? And apparently we do. So we can go ahead and cancel one from the top with one from the bottom. Then we look at the 4. Is there a factor of 4 in the denominator? And there's not. So then we go over to the x minus 7. Is there an x minus 7 on the top and the bottom? Apparently there are. So those can go ahead and cancel, which leaves you with your final terms that just need to be multiplied together. So we multiply the numerators, multiply the denominators. So 2 times 4 gets you an 8 over 3 times. Apparently there's nothing left down there, so that's just going to be a 3. So that leaves us with an 8/3 for our final answer. Okay, so that's number 9.